We're going to keep on working with fractions. The only reason why we call these ones complex fractions is that we have a mixture of addition and division, or some sort of mixture of operations in there. So when you're looking at the three fractions, this time they want you to examine the least common denominator amongst all three of them. And again, you may remember the phrase of a common multiple. So in this problem, if you're looking at the 9, the 18, and the 3, what you could do is you could actually list out all the multiples, like starting with 3 because it's the smallest number, would be 6, 9. Okay, well that matches up with this 9, but it doesn't match up with the 18. So we could go on with the next multiple of 9 of 18. Okay, that matches up. Well, let's see if 3 gets there. 12, 15, 18. There we go. 18 is the common multiple. So that's the same thing. The least common multiple, or the least common denominator, is the common multiple. So what they want you to do is look at that 1/9. And what you have to do to get it to a denominator of 18, well, you have to multiply top and bottom by 2. And then, I guess, same thing on bottom. If you have 1/3 and you want to get to the denominator of 18, to multiply top and bottom by 6. 3 times 6 is 18, so 1 times 6 is 18. I think what they actually wanted you to do, though, is take each one of those pieces, the 1/9, the 1/18, and the 1/3, and just multiply the top and bottom by that 18. And the reason why this works is if you distribute that 18 to each piece, well, 18 divided by 9 would be 2, 18 divided by 18 would be 1, and 18 divided by 3 would be 6. And now the problem becomes a little bit easier to work with because 2 plus 1 is 3. I'll just write it over here. 6, which equals 1/2. I know I'm kind of all over the place on that one. But this is acceptable because by multiplying the top and bottom by the same number, essentially what I'm doing is multiplying top and bottom by 18 over 18, which equals 1, and multiplying by 1 will not change the value of something. Just think about that for a second. So we can do that on some of these more complicated things. So the first one starts off the same way of thinking about the least common multiple of 2, 10, and 5. And in this case, the least common multiple would be 10. I can show you ways of finding the common multiple, but right now I'm just going to assume that you're familiar with that. So I can multiply top and bottom by 10, and as I distribute that into each one of those, well, half of 10 is 5. 10 divided by 10 is 1. Let's see, 10 times 2 is 20, divided by 5 is 4. So we're looking at 4 over 4, which equals 1. And this is actually a problem you could check with a calculator, but I don't want you to rely too heavily on a calculator. So if you look at the next one, the common multiple of all of these is the 3 and the x. So I'm multiplying top and bottom by 3 and the x. So as I distribute this into the problem, well, 3 divided by 3 is 1. You still have 2x there. And on the next one, x divided by x is 1, but you still have 2 times 3, which is 6. On bottom, really the same thought process. 3 divided by 3 is 1, but you have 5x. And in the next one, x divided by x is 1, but you still have 5 times 3, which is 15. And now there's nothing we can do. Well, I guess we could do something. So I guess that we're not done, because I didn't think about the greatest common factor, because that's what we have on this one, is I can pull a 2 out, and I'm left with x plus 3. And on bottom, same thing, I can pull a 5 in front, left with x plus 3. And now I can cancel out. Hopefully I did my arithmetic correctly there. So that final answer is 2/5. And then I have one more on this side. And what's tricky about this one is a common multiple between 8, 4x, 2x, and 4 is actually 8x. And again, I'll save the explanation on least common multiples for anybody that needs it. 8x times 3. Well, the 8's will cancel, so you're left with 3x. And 8x divided by 4x would be 2. Now, if you look at the next one, 8 divided by 2 is 4 times 7 is 28. And those x's cancel. 8 divided by 4 is 2 times that 3 would be 6x. And I don't think anything cancels, but you could greatest common factor in the denominator just to see. But yeah, I don't see any like denominator or anything like to cancel out on that one. So hopefully I didn't make any mistakes there. So as we get this more complicated, sometimes the greatest common factor, or least common denominator, I should say, has an x squared in it. 2x squared. 2x squared. And again, as I distribute into the problem, the 2's will cancel, and I'm left with x squared. And then the second piece, the x squareds cancel. 2 times 2 is 4. And then on the next one, that doesn't really look right. Let me try to fix that. There you go. Well, 2 and an x cancels, but I still have an x on that other problem, so 3x. And then 3 times 2 is 6. And both the x squareds cancel. But this time we can practice some of our previous skills, because in the numerator, you have x plus 2, x minus 2. And on bottom, you have a greatest common factor. A 3 can be pulled in front. And from there, you can cancel out an x minus 2. And there's your best answer, x plus 2 all over 3. And it might just take some practice. I'm not going to say that this is easy. I'm sure I'm making it look easier than what it really is, because the greatest common factor in the next one is 5x squared. I should say the least common multiple. Because as I distribute the 5 into the problem, the 5 will cancel, but you're left with 2x squared. 2 times 5 is 10, and one of the x's will cancel on the next one. And then on the next, one of the 5's will cancel, one of the x's will cancel. You still have one though. But then if you look in the numerator, you can factor out a 2 and an x, and when you do that, you can actually cancel out with the x minus 5 on bottom. So what's that final answer? It's simply 2x, or 2x over 1, but that should be good. And let's make it a little bit trickier, is throwing in 3 fractions. But the least common multiple in the denominator is still going to be a 12 and an x. A 12 and an x. So now on top we actually have 3 places to distribute. The 12's cancel and you're left with x squared. 12 divided by 6 would be 2x. And then the x's cancel, but 2 times 12 is 24. And the next one, the 12's cancel, but x squared. Let's see, 12 divided by 3 is 4, times this 4 would be 16. Well, we can factor that. On top, x plus 6, x minus 4. And on bottom, you have your difference of squares again. X plus 4, x minus 4. And what happens there? The x minus 4's cancel, and there's your answer, x plus 6 over x plus 4. And there's ways that you could double check that you have the right answer. But let's get to the trickiest of problems. And there's just 2 of them, but it is to your benefit if you factor everything first. So as I look at the denominator, I'm just going to work with the denominator real quick. I can see a 12 goes out of that, x minus 2. And then I can also factor the other piece. The other piece being x minus 4, x plus 2. Well, there's going to be your common denominator that you can multiply top and bottom by x minus 4, x minus 4, and x plus 2. Same thing with the bottom one, x minus 4, x plus 2. So what I like about this is all the denominator ones cancel, and so what we have in the bottom is just 12 and x minus 2. But if you look on top and you start to distribute that in here, so it's this entire quantity that's being distributed. Well, the x plus 2's will cancel, but what you still have is 4 times the quantity of x minus 4. Same thing with the next one, is the x minus 4's cancel, but you still have 2 times the quantity of x plus 2. So what I would do is I would see if I could simplify anything on top just to see. I have 4x minus 16 plus 2x plus 4, and combining like terms on top, I have 6x, what's that, minus 12? Really, I should be rewriting this each time, because if I'm looking at the numerator now, hopefully I did all that correct, I could factor out a 6 on top. Well, kind of had a feeling that that was going to happen, that the x minus 2's will now cancel, and 6 over 12 reduces to 1/2. So that very complicated fraction simplified all the way down to 1/2. I'm not saying they're all going to come out to something that nice. And you might want to hit pause in the video as I go back and start the next one. But again, the advice is to try to simplify where you can, like x plus 4, x plus 6, x plus 2, factors of 12 that add to be 8. Hopefully we've done enough of these where it becomes more obvious. I don't know if it really has though. But if you look on that problem, switch over to green, we have x plus 6, x plus 2, x plus 6, x plus 2. So that's what we have to multiply top and bottom by. X plus 6, x plus 2. Only works if you multiply the bottom by x plus 6 and x plus 2. So as far as the bottom goes, that's kind of nice, let's use this color, that both the x plus 6 and the x plus 2 cancel, and on bottom you just have the x plus 2, x minus 2. But as you distribute on top, it's this entire quantity I have to distribute in here, is that the x plus 6 cancels, but I have this x to distribute to x plus 2. And then minus that 1, the x plus 2's cancel, I have to distribute 1 to x plus 6. So as I go to simplify on top, I have x squared, I have a positive 2x minus 1x, so that would be plus x, and then distribute, I guess I'm assuming you're good at, I'm doing 2 steps at once here, minus 6. Because on top, I think you can see that factors. What are factors of negative 6 that add to be 1? X plus 3, x minus 2. And why would I ask you to do that? Well, then you can cancel out the x minus 2's here. X minus 2 and x minus 2 cancel. Here's your final answer. I'm just not rewriting it. And you should be ready for your homework.